Numbers are growing here for participants. As I mentioned earlier, we'll wait a minute yet to start the webinar as people are starting to join. All right, I think we'll proceed. We've got most of the people on that we can see as participants. And first of all, I'd like to thank everyone for joining us. Good morning. Thank you for taking time out of your busy day to be a part of this webinar. My name is Steve Wille. I'm a senior project architect and one of the owners at Hoffman Planning, Design and Construction. Through the magic of technology, I'm joining the webinar from the comfort of my own living room. And I've got a little bit of remodeling to do yet. Today we'll be discussing how to improve indoor air quality during COVID-19. So, next slide, please. Why are we here? Well, knowing that as humans, we spend nearly 90% of our time indoors, and also knowing that COVID-19 virus can be passed in multiple ways, including through the air we breathe, maintaining clean air within our facilities is one way to slow the spread of the coronavirus. This webinar is the next in a series that focuses on how to address COVID within the built environment, and will focus on indoor air quality. We hope the information you gain from this webinar will help instill confidence with your healthcare workers, your patients, your students, teachers, parents, employees, seniors, and everyone else that enters your facilities. It was evident during our last webinar, given the amount of questions that focused on indoor air quality, that it was a large concern during this time. As many facilities continue to reopen and the number of COVID cases continues to climb, a major concern is how to maintain clean indoor air quality. This webinar is intended to be a community outreach and community service effort, with Hoffman providing building solutions over 125 years, and our presenters from Garot and JF Ahern providing facility solutions that deliver mechanical system comfort, efficiency, and functionality. We thought this would be a great time to conduct this webinar. Even though these two companies are competitors at times and design builders of facility mechanical systems, when we approached them both about this webinar, they graciously agreed to participate as a way of giving back to the larger community. Next slide, please. We would like to thank Optima, New North, and the following chambers: De Pere, Fox Cities, Greater Green Bay, Heart of the Valley, and Oshkosh for promoting this event. Hopefully you're able to use some of the information we share today as you open your facilities. Now it's my pleasure to introduce our presenters for today. Josh Jackels is a construction sales manager with JF Ahern, who has 15 years of experience in the mechanical and plumbing industry. Josh holds a Bachelor of Science in Mechanical Engineering from UW-Platteville, along with a State of Wisconsin Master Plumber's License. His current role involves front-end pre-construction design, estimating, and budgeting services, along with business development. Kevin Bahr is the Director of Service and Building Automation at Garot Mechanical. Kevin has been involved in many aspects of the HVAC and building maintenance. He has 20 years of experience working for mechanical contractors in various roles, and 10 years of experience in facilities management, including Director of Public School Facilities. Kevin has an associate degree in HVAC and refrigeration, has steam fitter apprenticeship, and is certified WASBO, Wisconsin Association of School Business Officials, facility manager. Next slide, please. A few housekeeping and logistical items. Before we get started, all attendees are automatically muted with video turned off. Also, this session is being recorded and will be distributed to all attendees the day after the webinar occurs. Question and answer will be addressed toward the end of the session. And at the bottom of your screen, you'll hopefully notice a Q&A button that you can submit questions throughout the presentation. Next slide. So for the agenda today, it'll be 60 minutes and will be divided into two sections, an approximate 40 to 45-minute PowerPoint presentation and 15 minutes of question and answer made available to the audience. First 45 minutes will be broken into four main topics. Josh will cover HVAC 101 to baseline everyone with quick HVAC basics, review of mechanical system types, and there will be a poll where we'd like everyone's participation. And also, he'll review industry recommendations from CDC, the Center for Disease Control, as well as ASHRAE, the American Society of Heating, Refrigeration, and Air Conditioning Engineers. Kevin will take over after that and will review strategies for improving building ventilation, which involves introducing fresh air to your facility. Third, Josh will come back on and review available approaches and strategies for treating indoor air quality during COVID-19. And finally, Kevin will review components of a management plan to help instill confidence in your facility occupants that you are looking to prove you're looking for safety as well as looking out for their health in providing cleanest indoor air possible. The last 15 minutes will address any questions you may have. So let's get started. I'll hand it over to Josh to start talking about HVAC 101.
Welcome everyone to the webinar. As Steve noted, we are on today discussing indoor air and more specifically, recommendations that are out there and what we have seen through the industry as the latest trends to assist with indoor air quality. Before going into detail of COVID-19 HVAC recommendations and trends, I wanted to start with a little HVAC 101, a basic look at a couple typical HVAC systems, as well as typical maintenance on these systems. Two systems that are pretty standard to facilities are rooftop units as well as air handling units. I am sure many of you have one and or both types of systems installed at your facility. Next slide. Starting with a basic air handling unit, the basic functionality of the AHU system is to provide conditioned air to the facility. Fresh air enters the unit, passes through a damper, a series of filters, and crosses the coils and is delivered, and air is delivered via the supply fan to the space. As noted, there are a series of filters installed to ensure dust is collected, similar to the filter on your furnace at your house. These systems are typically connected to chillers and boilers to provide the heating and cooling. AHUs can be located inside a facility in a mechanical room or penthouse, as well as, like the RTU, they can also be placed outside. Next slide. Another common HVAC system, the rooftop unit, RTU, also provides conditioned air to the facility. RTU systems, as their name suggests, are usually located on the roof or exterior to the facility. Packaged air conditioning units are very popular because they are compact, self-contained, all-in-one HVAC units. RTUs perform similar to the AHU, although not connected to the plant level components. Now, let's get some feedback on the types of facilities our guests are part of, as well as determine the HVAC system types that are in these facilities.
Thanks, Josh. This is Steve again. As a way to introduce a little more interactive mode, we'd like to get an idea of the types of facilities that our audience members operate within. The reason for this poll is to better understand our audience and to tailor some of our talking points as we move forward. Please take a few moments to answer the question that best fits your situation. On the screen, you'll see what is your primary facility type, whether it be healthcare, education, government, commercial, manufacturing, senior living, or other. If you would, please check one of those and hit the submit button, and we'll hopefully have some results instantaneously. I'll give this a few more seconds to have people answer. Looks like we have most of them, so I'll count down from 5, 4, 3, 2, 1. All right, so as you see potentially on your screen here, healthcare 3%, education 17, no government, commercial 17, and manufacturing is the largest at 23%. Appreciate everyone taking the time to do that. We are going to do one more poll question. And this one addresses the types of air distribution and mechanical system that your facilities currently employ. Please do the same as the last question, provide the answers that apply to you. If you do not know the type of system that you have, no worries. There's no shame in that by any stretch of the imagination. This is common, actually. We'll give you a few more minutes or moments to answer this one. Looks like we have most people answering. I'll close the poll here in 5, 4, 3, 2, 1. Resoundingly, we have air handling units, variable air volume system as being the most utilized on the audience, within the audience, followed by constant air volume, and then rooftop units as being tied for second. Minimal after that with regard to furnaces, no heat pumps, and hydronic hot water round out the majority of the respondents. Very much appreciate everyone taking part in this. We'll continue on with the presentation at this time, going back to Josh.
Thanks, Steve. Along with understanding your system type, there are several recommendations for standard maintenance to ensure your system is running properly. As noted, these include coil and drain pan cleaning, filter replacement, as well as verification that your system is running as designed. These items, along with several others, will assist with keeping your building running properly. Please reach out to your local contractor if you need assistance with building system review/maintenance updates. As you can see in the picture, sometimes systems are not maintained, therefore non-consistent with required upkeep. Building maintenance is similar to owning a car and regularly changing the oil, checking tire pressure, as well as filling up your washer fluid. Without these items, your car may not perform to its peak level. Next. Now that we've reviewed a few standard system types, along with standard maintenance, I would like to discuss the COVID-19 HVAC recommendations that 2 trusted industry organizations have provided. These 2 organizations are CDC, Center for Disease Control and Prevention, as well as ASHRAE, American Society of Heating, Refrigeration, Air Conditioning Engineers. Please note that other sources, such as the recently released DPI guideline for school opening, also reference HVAC measures to try to combat the COVID-19 virus spread. I am sure many parents are starting to provide feedback on comfort level for sending their children back to school this fall. Next. The first recommendations I will go through are provided by the CDC. As you can or cannot read from the slide, CDC has numerous suggestions, including improving ventilation, increased airflow, disabling demand control ventilation, as well as increasing air filtration to a MERV rating as high as possible, plus many others. As you can see, I have boxed both improving ventilation as well as UVGI, both of which will be further discussed later on in this presentation. Next. The next recommendations I will review are provided by ASHRAE, which is a noted HVAC industry leader in codes and recommendation. ASHRAE's COVID-19 recommendations are very consistent with what CDC has suggested. Increase outdoor air ventilation, adding duct or air handling mounted upper air or portable UVGI devices, as well as improve HVAC filtration with a noted MERV rating of 13. I again boxed in the discussion points of outdoor air ventilation as well as UVGI, as we will expand upon these topics further on in its presentation. Now that I have noted some industry recommendations provided by both ASHRAE as well as CDC, Kevin will provide more detail on the discussion topic of strategies for improving ventilation.
Thank you, Josh. Good morning, everyone. Just wanted to run through and give a brief explanation for some of the recommendations that CDC and ASHRAE have put forth. Next slide, please. Strategies for improving, one of them, increase the amount of outside air to your facility. In the poll that we completed, the top two were an air handling system or a packaged HVAC/rooftop unit. There's two pictures on the slide that show the layout and application of both of those items. You notice on the rooftop one, it mentions in the picture an economizer. So your systems, if you do have economizers, a device that is often used to save energy and cool the air in your building with cool external air or ambient air in certain applications. With this situation, the economizer would be manipulated and you would increase the amount of fresh air ventilation to your facility. If you notice in the top graphic, it does not say the word economizer on the air handler pictorial, but it does show by the word linked how the dampers are modulating together. So if you take 100% outside air, your return air goes to a percentage of 0. As you manipulate these items, be aware of some increased energy usage. If it's a cold weather day or a hot, humid weather day, and you are bringing in outside air to your facility at that volume, it may cause some challenging times for your mechanical systems. Also note, if you do manipulate those things, where they were originally set. So you can go back to that if we get to a point of normalcy. Most air handling unit and package units have the capability to adjust the outside air. The amount of outside air into a facility is dictated by code requirements and sometimes specific requirements to your process or facility. As you change these, you're overriding the minimum amount for your design. And obviously the word economizer has the word economy in it. So you will spend more on your utilities. Be aware that if you are bringing in more outside air, it can create some pressurization issues in your facility. Some of those could cause simple problems to your doors stay open. If you have a card access or security system, that can be problematic because if your doors stay open, it does inhibit your security. Increasing the amount of outside air can be achieved through your building automation system if you have one. But don't forget, we live in Wisconsin, and if you adjust these things and override them now, please put a reminder to yourself somehow that when we get into the colder weather, with your original design, if it wasn't applicable to that volume of outside air, it may cause some inherent issues in your facility. Next slide, please. Another strategy is just to increase the amount of airflow from your existing system into your spaces. This can be done. It has a couple more challenges to it. Just gave a tutorial and a picture of a typical furnace, a residential furnace. So if you wanted to increase the airflow and you have a furnace in a small office application or in a small area, I have a picture of the door being off. It's not like it's belt driven or there's a little speed control on the side. It'll probably require someone from your facilities department or a contractor to assist you with that. I also show a picture of a typical air handler VAV system. Those systems are originally designed for your minimum airflow requirements for fresh air, minimum heating, minimum cooling, maximum heating, maximum cooling parameters. If you override those particular items through your building automation or manually, please record where they were to start with so you do not deviate away from your building design. A couple things that may occur is if you increase the amount of airflow in your traditional spaces by doing these recommendations, you may cause some discomfort with too much air blowing on people, create some nuisance calls. You may need an air balancer to assist you with this one if you choose this route, so they can reference the original status versus the manipulated status of your system. Next slide, please. Another recommendation is to disable your demand control ventilation. Demand control ventilation can be seen in multiple facilities. It could be in your office facility, or it could be in a municipal kitchen or municipal garage, county garage, repair facility where vehicles are present, in a kitchen. It is an energy saving aspect that has been strongly used over the last 10, 15 years. In traditional spaces of offices, they utilize sensors, carbon dioxide sensors. As the level of carbon dioxide increases, the amount of outside air increases. These are code compliant systems of manipulating and monitoring the amount of outside air that you bring into your facilities. So to override them, you are overriding a method that was installed to save energy. You will increase the amount of outside air by overriding them, typically. But please be cognizant that your system does go to a normal operating mode as a default. Some demand control ventilation systems have an override built right into them. Just confirm your system's overall operation if you do override them. Next slide, please. Another simple one is just to improve ventilation with natural ventilation. Windows, doors in your facilities, if you have operable windows, you can utilize those. Make sure that your windows are closed before leaving for the day. If you have a facility with multiple classrooms and you're communicating to people that you're going to improve your ventilation by doing so, make sure you have your staff check at the end of the day, or same goes for your office facility. It can be challenging to have your mechanical air conditioning systems work properly if you enact this policy to open windows and you have operable windows. Good practice of clear communication on the onset of doing this through just a global email within your company or school district, telling them what you're doing. Because when you have these windows or doors open, I would assume you wouldn't be running your mechanical cooling. So on cooler days, cooler weather conditions, lower humidity, this one, on different from the last couple slides, can save you money, but only through good communication where you're not doing the mechanical cooling and the natural ventilation at the same time. Make sure your window screens are in, because we all do not like pests, wasps, and mosquitoes and flies getting into our facilities. It's a good practice, and it can work very well with communication. When I worked for a school district, we would email the whole district and give them a game plan for the day or for multiple days if we've seen a mild weather, low humidity forecast in the future. And truthfully, students and staff did enjoy having the windows open where we were able to have operable windows function. Next slide, please. Another strategy for improving your ventilation is through air filtration. I'm assuming you all have air filters in your systems, and traditionally they're a lower MERV rating, possibly an 8. A MERV rating is, MERV stands for minimum efficiency reporting value. It's how their particulate capture capability is measured. As you increase to a higher MERV filter, which this seems like an easy resolution, you take your filters out and you put in a MERV 13 or higher, just please be aware. It seems like a simple solution, but it can affect the operation of your mechanical equipment, because the higher MERV rating, even though it removes more particles, it has quite a bit more pressure drop. If you identify the slide in the lower left corner, it shows the particular MERV ratings, 13, 14, 15, and you'll notice that it can capture more particulate, but the pressure drop increases dramatically. So if you had a conventional air conditioning system and you took a MERV 8 filter out and you put a MERV 14 or 13 in, the pressure drop increases. It'll reduce the airflow across your air conditioning system, and it may cause some mechanical issues or your air conditioning system to potentially freeze up, counteracting everything you were trying to do by increased airflow or more filtration. As you're studying this and you're looking at doing this, please evaluate your system and its capabilities, because as it can be very productive and you could handle this internally with your team. Just make sure that your homework is complete so you do not have any mechanicals or airflow reduction issues. Next slide, please. Strategies for, just more air movement. One of them, this is probably one of the most simplistic ones. Instead of having your ventilation system operate on a time clock, again, for energy purposes, and when no one's present, there's no need to ventilate. You go to unoccupied modes. You can manipulate your system to run 24/7 or for longer durations of time that it is now. You'll have a lot more air changes in your space, less stale air. It'll improve the capabilities of purging some of the things from your spaces. It can be done. Some older pneumatic control systems may have a timer like in the bottom right. That's a mechanical timer. If you have some rooftops or furnaces, you may have a conventional thermostat or an electronic thermostat that you can adjust your schedule with. And in your buildings that have building automation, you should have a system that you can access as a customer to manipulate your run hours and your schedule. And again, you'll increase your energy usage, and you're going to increase your maintenance cost. And to explain that a little bit, as you're running, if you're only running 10 hours during the day and now you go to 24 hours a day, your filters are having air pass through them 24 hours a day. The belts on that unit are seeing a dramatic increase in operation. So you want to put a reminder out there to increase your amount of maintenance on these particular items if you choose this direction. Next slide, please. This one's interesting, the verbiage of it: generate clean to less clean air. In our practice and reviewing this slide, it can be difficult to explain this one, and I'll give you an analogy, but it's to maintain higher pressure in some occupied spaces than in surrounding spaces. And you can do this by manipulating the airflow in your system. Again, I'd recommend somebody from your staff or a balancer, air balancing person, to document where they were prior, because that should adhere to what your initial design was. And after the fact, also document where you set them. The purpose is to keep a higher pressure in a space to not allow surrounding spaces, that air from the surrounding spaces that may be contaminated to enter the higher pressure space. I'll give an analogy because it's the easiest way for me to explain it. It's commonly used in healthcare and food industry and specialized manufacturing to keep contaminants from the airstream or other spaces away. In the food industry, you may have a process area where they have open and raw food product. They maintain that process area at a higher air pressure. They have more air volume that when you were to open a door from that space to a cold storage warehouse or a packaging area, the air from the higher pressure area relieves into those areas. The air is always pushing outward to eliminate or minimize the amount of contaminant that could come from a warehouse or a cold storage area into a food production room. So these are common practices used in industry that could be utilized in your everyday spaces if they were classrooms or offices. And it will take some recording and some data and some assistance from a balancer or a contractor to verify that you can maintain that pressure. With that said, next slide introduces Josh again, and he will review some of the treating indoor air quality measures that you could use.
Thanks, Kevin, for sharing your thoughts on several strategies for improving ventilation. I am now going to discuss two COVID-19 strategies, one of which was noted from both CDC as well as ASHRAE, as well as a newer strategy. Please note, I am not siding with either specific strategy and will not sell to a specific vendor, but want to ensure as a community, we understand potential strategies for our facilities. Next. And now on to the sizzle portion of the presentation, where I will discuss two of the latest COVID-19 HVAC trends that are being discussed for both new as well as existing facilities. On the left is UVGI or UVC, ultraviolet germicidal irradiation. UVC lights are installed similar to the photo on the left with the target of mitigating viruses and bacteria. UVC kills all known microorganisms, including bacteria, viruses, molds, as well as other pathogens. Viruses that are susceptible to UVC inactivation include influenza, measles, SARS, and smallpox. On the right side is BPI, or bipolar ionization. Although not noted as a strategy from either CDC or ASHRAE, BPI has been tested and proven as a means of treating COVID-19 and HVAC systems. BPI systems are installed to generate positive and negative ions. The airborne particles are charged, causing them to cluster and inactivate viruses and bacteria. BPI is an active technology, meaning the system seeks out particles and pathogens. BPI has benefits noted as particle reduction, odor control, as well as pathogen control. Although both strategies are also noted to remove odors as well as control coils. I will now dig deeper into each UVC as well as BPI, discussing the science, applications, and considerations for each. Next. The first strategy I will discuss in more detail is UVC. Here is a little bit of the science behind it. UVC is a portion of the UV spectrum as seen on the graphic. UVC lamps produce about 90% of its energy in UVC wavelengths, 4% given up as heat, and the rest as the visible light range of medium blue color. Typical UVC is at around 220 to 280 nm wavelengths. Around 254 is the ideal frequency level at which DNA absorbs the most UV light. You can see that on the little pictorial view at the 254 is the ideal. When exposing microorganisms to UVC light, the light penetrates through their cell wall and disrupts the structure of their DNA molecules, prohibiting reproduction. ASHRAE states that UVC wavelength can kill 90% or more of all microorganisms living on HVAC air ducts and evaporator coils, depending on UVC intensity, length of exposure, UV lamp replacement, as well as lamp life cycle. Research has shown that UVC is a practical and cost-effective method of inactivating airborne viruses, mycoplasma, bacteria, and fungi on surfaces. Next. As seen in the pictures, UVC can be applied to RTUs, AHUs, as well as used as surface mounted, as noted, upper room applications. Upper room applications, as shown in the small middle picture, are ideal for infection control and work by interrupting the transmission of airborne infectious diseases in areas such as ER rooms, cafeterias, classrooms, and churches. UVC lights can also be installed in the ductwork, as shown on the left picture. For specific sizing and applications, please reach out to your preferred vendor or contractor to assist. Next. When considering UVC, one must think of bulb life. Typically, this is around a 1-year cycle, although inspection every 6 months should be performed. There's also the question of where do I install it in my system? As noted previously, inside the unit, ductwork, or in the room are options. If using upper system, the guidelines suggest no more than 6 air changes per hour, which is due to the fact of the particles may not be exposed to the UVC if the ventilation rate is too high. In terms of air changes per hour, that is a metric that tells us how many times an HVAC device can fill up the full volume of the room with air. Although I noted that UVC is documented by both CDC as well as ASHRAE in terms of a means of fighting COVID-19, researchers don't know yet if UVC can kill COVID-19 as the strain has not yet been studied. Next. One of the more popular trends for treating COVID-19 in HVAC systems is the utilization of bipolar ionization, or BPI. A little science behind this strategy as well. BPI is created when an alternating voltage source is applied to a tube with 2 electrodes. When voltage is applied to the tubes, an ionization field is produced around the tube. The ionization cannot be seen. The system seeks out particulates and contaminants and does not wait for the particulates to get into the filter. As noted, BPI is an active technology that is always seeking out particles and pathogens. BPI has recently been tested and validated to render the virus ineffective. Lab results were released in early June. BPI has been installed in the White House, airports, airplanes, higher education, as well as many other facilities. And as a side note, both Garot as well as JF Ahern have invested in BPI systems for their own facilities. Next. Similar to UVC, one can apply BPI inside both RTU as well as AHU, standalone units, as well as compatibility with VRF type applications. BPI bars are installed for coil cleaning, odor control, as well as pathogen control. Building automation controls can be connected to your BPI system to measure and verify items such as unit on and off, as well as meter ion and particle levels. Again, please work with your vendor for sizing and specific application questions. Next. The recommendations for BPI, as shown in the boxed in area, would be after the filters due to the product being an active technology. There's also other things to think about in terms of location of install, depending upon what you're trying to serve, as well as power supply requirements. I will now hand the show back to Kevin to discuss facility management plan examples.
Thanks, Josh. Just want to review a couple things in regards to just your everyday management of your HVAC systems. Next slide, please. Preventive maintenance. This should be occurring now. It's nothing you have to purchase beyond with any apparatuses, UV lamps or BPI. This is inherent thing that hopefully you're doing. If you are got a good piece of the puzzle already in place. It gives many benefits. And I hesitate to recommend any deeper solutions of any alternative products or filters or UV lamps prior to having a good handle on your current maintenance of your HVAC systems. If your systems currently don't supply enough airflow or coils are dirty, those are things that you need to look into first. Those are low cost, low hanging fruit solutions. That's a great place to start with your staff or reaching out for some assistance. It comes with multiple benefits to have this management plan. It can reduce your operating problems and your service calls, customer comfort for your staff, for employees, extend the life of your equipment, conserve energy, reduce emergencies, control your maintenance budget, review and optimize your HVAC equipment schedules just to make sure you do not have things running on periods when you don't have occupancy if you do not desire them to run. But this mainly in today's conversation, if you are doing maintenance right now, it's a great reference point and a great tool for you to utilize to provide reassurance to your customers, occupants, and employees about their indoor air quality. If you have a good plan in place, it is a wonderful time to share that with your leadership, your community, and you could have documentation on hand. Next slide, please. In regards to public school systems, in 2009, Act 96 was put in place to provide an indoor environmental quality plan. If you are a school district and have been or haven't been utilizing this, it is a good set of ground rules to follow. And it does adapt to some of the questions I'm sure you will be getting from community, staff, students in our times. If you have been doing this and you have things in place, it is a great tool to utilize to explain and share with the public things that have been in place, and you can add an addendum to it to relate to what you're doing with COVID, maybe related to some of the practices today by just increasing your runtime on your air handlers or your outside air. It's a great tool to utilize. It's a good rough draft, can be found online under DPI to assist schools in creation of a plan if you haven't put this in place. If you have been utilizing it, like I said, it's a great practice and thing to share with the public. And it is a public document. So if you're not a school industry, there's some great tools and recommendations in here, and you can look online and find this to utilize in your present facility, even if you're not a school district. It at least gives some good practices to follow. And you can add a COVID section to your plan. With that said, I'd like to turn it over to Steve for some takeaways and questions and resources.
Next slide, please. So just as a wrap up before we get into question and answer, just some takeaways and some resources here. Obviously, with both CDC and ASHRAE, they have the recommendations. We've tried to package and basically coalesce a lot of the different items that really pertain to the COVID piece of things as we went through this presentation. You heard Kevin talk a little bit about optimizing your system and making sure that it's working properly, because if you're adjusting a system that's not working properly, it certainly won't produce the results that you're looking for. Obviously, we're looking at making sure that your system specifically, as we saw in the poll, there are many different types of systems out there. Make sure that you determine what system you have, and to make sure that what you're doing to it is going to result in the recommendations and the different things that might help the system itself produce the results that you're looking for. The COVID strategies that Josh went through with UVC and bipolar ionization, we obviously reviewed as well, and trying to give you at least a little bit of components to a management plan as well. Hopefully that helped with some of you moving into the future. Next slide, please. These are just some of the resources that we had referenced when you see CDC, ASHRAE, the Energy Code, Environmental Protection Agency, as well as air conditioning and heating, refrigeration news. Next slide. Q&A. So thank you for all of you who submitted questions. I'm going to go through those right now, not in any particular order. We have about 14 minutes left to address these questions, so we'll get right to them. The first one is, did I hear correctly that UVC is not proven to kill coronavirus? I think both of our panelists and experts can answer this one, but I think I'll start with Josh on this one. If you could maybe give us a little background on and answer this question.
Sure. As discussing our presentation, we were fully aware this was probably going to come up as a question. Citing, I guess, UVR or uvresources.com, the specific language out there is researchers don't yet know if UVC can kill COVID-19 as a particular strain. Although they're pointing out that the germicidal UVC at around 254 nanometers, as I alluded to earlier, is effective in killing other varieties of coronaviruses such as SARS and MERS. They're not positive on the impact of UVC on COVID-19 itself.
Okay, thank you, Josh. Another question, and this one I'm going to probably ask Kevin to weigh in on. So if increased filtration is not able to filter out COVID, is it really better to focus on airflow instead of filtration?
That's a great question. I'd give you my personal opinion. I would increase the airflow to spaces. I would increase the amount of air changes, and that if it's through natural ventilation or increased airflow. The filtration, you're trapping items in a space, and if you're not increasing the amount of outside air or natural ventilation, you're continually recirculating air through those filters, no matter what MERV rating you're using. So to exchange the air as often as possible would be my recommendation.
All right, thank you, Kevin.
I would also suggest that each system type and facility type are a little bit different in their own. So I would suggest doing a review of your system and possibly reaching out to one of the industry folks to confirm and suggest, requirements.
All right, thank you, gentlemen. The next one, and we knew this would come, what's the cost of a standalone BPI unit?
That's a great question.
I'm not going to direct that to anyone, both. That one we knew was coming, and obviously everyone's system is different, but I'll refer to Josh and Kevin on this one.
I think Josh and I have both been involved with this, and that's a question we've had presented to us multiple times over the past 2 months. It's really dependent on the size of your system, the CFM rating. If you have a smaller rooftop unit, it's in my opinion, it's quite inexpensive. And the great thing about either the UV or the bipolar, there are additional items you can add to your systems. And even though the UVC isn't tested for coronavirus, not COVID-19, both of these items do many other things that are positive for your environment. If you were to put it on a large air handling system in a hospital versus a small rooftop unit for an office, there's definitely a price differential. There's multiple products in that line, different manufacturers. And, from the rooftop unit applications, the smaller applications, I think it's pretty cost effective. And both of them also, there's an inherent, if you do your research online, there is an ASHRAE standard that does allow you to reduce the amount of outside air into your facilities. If your facility was designed to bring in, for example, 4,000 CFM of outside air, if you follow the practices and have it designed correctly to utilize that an ionization product, you can actually reduce the amount of required code outside air if you have those items in place. The reason I bring that up, it may be one way to justify the cost of installing them. So the cost can be anywhere, potentially on a small unit, potentially $1,800 to, if you have some very large air handling systems, it could be upwards of $50,000. I know that's a very broad explanation, but it really is product specific. Josh, I'd appreciate it if you have anything to add to that.
I don't want to punt on this one, but I'm going to kind of punt on this one. It again depends on the application. I will allude to the fact that it is, on a office type application, perhaps in, a single RTU. I feel like it's very cost effective. You're looking at, I don't want to throw numbers out there because I'm sure there's folks on the call right now that perhaps sell these type of applications. But I think you could probably, for less than 15,000 installed on a roof type application, depending on the size, rough ballpark, that would probably get you there. So again, the number I just threw out there probably means nothing unless you would actually sit down with one of your industry professionals / your vendor to go through the specific application, system type, etc.
So I think, given a rough ballpark, obviously it depends on the system and the capacity of it, your CFM, your fan size, all that. As a follow-up question to that one, one question says, I assume one is needed at each air handler, and if so, how does that work with fan coils?
Yes, one would be needed in each air handling system, package rooftop unit, and in every HVAC ventilation device that you may have in your, if you have unit ventilators in your classroom and that's the only thing that provides fresh air or air circulation to that classroom, if you were going to enact this for your whole facility, you would need one in that space on the unit ventilator. So air handlers, rooftop units. Could you restate the question again, Steve, please?
So it was removed. I'm trying to remember exactly what it stated, but it was referring to whether you need it at fan coils as well.
Yeah, there was a note about rough ballpark cost per installation and how it would apply to, I believe, fan coil units.
Right. You answered the actual air handler. Now the question is, how does it apply to the fan coils?
Yeah, unit ventilator, fan coil, the less costly to install on that device. Everything, the cost is based off of how many CFM a particular piece of equipment can push and supply. So the larger the CFM, the cost increase accordingly. The lower the CFM and the lesser the application, the costs come down. But they do have multiple devices for multiple aspects of equipment.
Okay. Next question is, does bipolar ionization create its own dangerous air by creating ozone? Josh or Kevin, thoughts here?
There is one particular product that gives clarification, and it's verified through underwriters' laboratories that it does not produce ozone. There's also, through one of the things I've already mentioned with ASHRAE, with the ability to reduce your amount of outside air per that standard, you have to have a system, your system has to be accredited and qualified as a non-ozone producing system. The multiple ones that I've looked into have that accreditation. You just have to verify that as you're researching them. A quality option should provide documentation and information that it does not produce harmful ozones.
All right. Next question is there a recommended CFM for COVID in classrooms?
CFM, air changes, I believe would be the proper verbiage. CFM could be, the classroom could be 900 square feet, it could be 2,000 square feet. So to give an answer specifically as CFM, that would be difficult without knowing the size and the number of students slash occupants. Josh, you have anything to that?
Yeah, I would say review the system type and application. So if it's a classroom, this classroom, depending upon what facility type, could be fed off, a single rooftop unit to a certain space, and or an air handling unit serving multiple spaces. So again, as we were talking about earlier, the specific application as well as amount of CFM is going to define the amount of BPI required for your system. So again, for that specific question, I would say, we could follow up with that, take that offline, and really evaluate your system type in the application and go through strategies.
Okay. We've got one more question, and it's more of a general question. Which is better, UVC or BPI?
Thanks, Steve. I'll kick that one off here a little bit. So I would suggest that, although UVC is recommended by both ASHRAE as well as CDC, the formal testing that I discussed earlier with the BPI strategy is one of the reasons why Ahern, as well as Understanding Tweet, has decided to go down that direction as well, installing them in our own units. So again, I talked about this previously. I'm not a salesperson to sell a specific model or manufacturer, but if it was presented to me as a facility, depending upon your system type and application, as of right now, I would probably be leaning towards BPI for the reasons that I stated.
Kevin, anything additionally?
Yeah, the statement Josh made during his presentation about checking your lamps on the UVC systems twice a year just to make sure they're in operation. That's important to recognize. It's not just an installation of a UVC system, it's the ongoing maintenance and the life expectancy of those lamps being 1 year. On the BPI systems, there's multiple systems out there, and there's very limited maintenance required to those systems. And they also can, it's based off of the free ions in your airspace. There's measurement tools that you can install in your system to give some peace of mind to your occupants, and you could visually display that. The measurement tools measure, like Josh had stated, contaminants and free ions in the air. So, if one is better, there's valid test results, and that's been provided to both Ahern, to Josh and myself, in regards to BPI, of what it does and the reduction of the maintenance needed on it. I know that's what my personal opinion, why we made this decision in our facility to go with BPI.
All right. With that, I appreciate your answers. To the audience, we appreciate your questions. We thank also our sponsors and advocates for making this webinar possible. To reiterate, this session was recorded and will be distributed to all attendees tomorrow. Again, we thank you for attending. Hope that This has provided some strategies for addressing indoor air quality in your facilities. And finally, we hope you, your families, and friends stay healthy and safe during this unprecedented time in our nation's history. Have a great day, everyone.
Thank you.
Thank you.